Hello everyone, so we are ready to see the results of our uh, experiment on the shuffler and to draw the winners of our raffle for 1000 gem codes. We will be drawing 3 lucky winners from those who participated in our event. All right, so just as a recap, and I'll just give you a summary. If you want the full details of the event, you can see that in the article about the event on EtherHub, which you can see in the description, the link of which is in the description of this video. So what we did was we took a deck with 60 cards and 24 lands, and we played 100 games with the deck on the ladder, best of 3. And for each game, we just counted the number of lands in the opening hand, and then we moved on to the next game. And what we wanted to see there was whether or not the number of lands in the opening hand that we actually observe out of those 100 games are in line with what we expect uh, if we consider that the shuffler is fair. So if the shuffler is fair in terms of shuffling the deck, ensuring that there's a random distribution of cards in your deck, that is consistent with how it would be if you were shuffling well on paper, then it would follow that the number of lands in the opening hand would have a hypergeometric distribution. Okay? And so in the opening hand of 7 cards, you can have anywhere from 0 to 7 lands in that hand. Right? So in those 100 games, we took note of how many lands we had in our opening hand, and you can see that on this column over here. So this is the column of the actual number of lands in our opening hand. By the way, so this is the data. Okay, so this is the data. So as you can see here, this actually counts how many of this raw data are 0. So if we ever drew a hand with 0 lands, then this will count that. That's why we're using this function here in Excel. All right, so we only had one instance of no lands. It's somewhere here. Can you try to find that? Okay, it's somewhere there. The recording is making my scrolling choppy, so I'm not going to. Okay, now it's fine. Yeah, there we go. That's the one instance where we had 0 lands in our opening hand. Okay, and then there were 17 times where we had a 1-lander. And then 29 times that we had 2 lands, and so on. Okay, so if the shuffler is fair, the actual probabilities related to each of those possibilities are provided here. So we simply use a hypergeometric distribution. So as you can see here, how we compute this, if you look at this the formula bar, you can see the function hypgeom.dist, which is the function for hypergeometric distribution, and it takes in 2 parameters: the deck size, which is 60, as you can see here, and the number of lands in the deck, which is 24, which you can see here. And then the false there is so that it will give us the probability for exactly getting 0. If you use true, then that will give you the probability of getting that number or less than it. So for 0, it's actually going to be the same, but for the others, it's not going to be the same. That's why we needed to put false there, so that here we're computing the probability of exactly 1, not 1 or less. Okay? So these are the probabilities, okay, the theoretical probabilities. And if we get the exact number of average occurrences out of 100 trials, these should be those average occurrences. So this tells you, so this is just like these probabilities multiplied by 100 will give you these. Okay. And so for this one, it's saying basically that if you draw uh, cards, if you draw hands 100 times from this deck, then you expect to see a no lander on average about 2 times on average. So we saw it only 1 time. So we saw less than what was expected. How about for one landers, you expect it on average to be 12. We got quite a bit higher, 17, right? But we're looking at the entire thing. Okay, so that's important because of course there's randomness involved here, especially since we are we are limited to a sample size of 100. Okay, so we have to look at all the entire thing. Okay, so how about for two landers, we expect about 27, and we did get something close. We got 29. How about three landers? We expected 30, 31, and we actually got 30. And for four landers, we expected about 19.6 or about 20. We got 18, also close. How about for five landers, we expected about 7. We got 4. For six landers, we expected 1. We actually got 1. And for seven landers, we weren't expecting it. And indeed, none of our hands were 7 landers. Okay? And so now that we have this, all that's needed to be done is to conduct the chi-square test. You actually see that here. This is the function for the chi-square test. All you need to do here is to enter your expected values and the observed values. Right? And we can see that actually in the function name. So see here, this is the actual range, I. So that's the actual range here, and then the H column is your expected range. Right? So and I blotted it out so that's to give a bit of suspense on what the result is. And as we talked about in the article, basically what you will see here is a p-value. And if the p-value is less than 0.05, then that means that we have reason to believe that the shuffler, that there's something wrong with the shuffler in terms of the number of lands in your opening hand for this particular configuration of your deck. Okay, so if the p-value is less than 0.05, and we know that the p-value can go from 0 to 1. Okay, and in particular, for this test specifically, for a chi-square goodness of fit test, the closer the p-value is to 1, it does indicate that the closer is our expected data to, the closer our actual data to the expected data. So the closer the value is to 1, the closer it is that we can say, the more it is that we can say that indeed the distribution seems to be coming from hypergeometric with these parameters. All right, so without further ado, let us reveal the result. Ta-da! Oh, so I mean, most of you probably figured it out already, right? So, so the result is the p-value is 0.74. So, big surprise, not really. There is no reason to believe that the data is coming from something other than what we expect it to be, which is a hypergeometric with a deck size of 60 and number of lands that is 24. So in other words, our actual data is a very good fit to this situation, which means in the context of this experiment, we do not have any reason to believe that the shuffler is broken. Applause, applause. All right. So in other words, the winners will be coming from the people who voted no, shuffler is not broken. And now let's get to that. So here we have the number of people who voted. So these are people who voted either on the article or during live stream. There are 24 total people, and that's why we are giving. So I did say I'll be giving away one 1,000 gem code for each 10 people who participate, and we have 24, then that's good enough for 3 codes. We don't doesn't need to be 30. 24 is fine for me. All right. So we will be giving away 3 codes, and in order to make this easy for me, so there are 19 people who are eligible for winning those codes. We're going to pick 3 of them, and I noted them here, 1 to 19. And so this will be in order, in reverse order of the comments on the article, with the last 3, because there were 3 that were from the chat. The last 3 will represent in order the people who registered in the chat, which I have here in this next sheet. Because I have them in order here. One is 17, one is 18, one is 19. So what's going to happen is that I'm just going to generate a random number from 0 to 1 for each of these, and then I'm going to order them according to those random numbers. And then the first three in that ordering, of course not 1, 2, 3, but the first 3 after we randomize, those will be our winners. Right? So I'm going to use the rand function. So the rand function actually gives you a random number every time you press any other key on Excel. It gives you, it's a fine function. It gives you a random number from 0 to 1 following a uniform distribution, which if we were talking about the discrete uniform, which we're not actually, we're saying that each number has an equal chance of occurring. That's essentially the same as in the continuous sense, but it's just that in the continuous sense, we can't talk about in the occurrence of individual events because the probability of that is 0. So it's a complicated discussion that I'd rather not have right now. So in any case, this is a fair this is a fair way of choosing the winners. Just yeah. Okay. So what I'm going to do is I'm going to hide this so we don't see the actual numbers until we're ready. Okay. And then so I'm going to just fill in the rand function. So now we have some random numbers there, and every time I press delete, those numbers are changing. We press delete a couple more times until we finalize. So these will be our final numbers. I'm gonna copy that and paste as value so that they will not change anymore. All right, so now they're not going to change anymore. So now we will order these. We will order these according to column L from largest to smallest. So the top 3 will be our winners. All right, so the winners are number 14, number 7, and number 19. All right, so I know number 19. Number 19 comes from Twitch, because that's the last person, right? So number 19 comes from Twitch. It says Melasauce. All right, so Melasauce. So this is basically 17, 18, 19. All right, so Melasauce wins one of the codes. And now let me go to, so let me write our winners here. We know that one of them is number 19, Melasauce. Let's figure out who number 14 and number 7 are. So I'm only, of course, going to count the ones who said no. All right, and we're starting from the top. And of course, this is only going to count those that are included. There were 2 more entries after I already closed the event, so those don't count, of course. So what am I trying to count? Number 7 first, number 7. All right, here we go. 1. This is not broken, so okay. Counts. 2, 3, 4, 5, 6, 7. All right. So number 7 is Whatsmada. Whatsmada is our number 7. The winner of the one of the 3 codes is what's Mada. And then the next one is number 14. So going from number 7, 8, 9, 10, 11, wait, 7, 8, 9, 10, 11, 12, 13, 14. And the winner is Rinz MTG. Rinz MTG. And you can verify this by going to the EtherHub article and counting from the top comment going to the bottom, the 7th, and then the 14th, not counting the ones that were entered after the entries have closed, and not counting the ones who voted yes, the shuffler is broken, because we are choosing our winners from the people who chose no, the shuffler is not broken, because that is the result of our experiment. All right, and so that's it. Here are our winners. I will announce this shortly on the EtherHub page as well and notify the winners. So thank you everyone for joining and tune in. I will be there. There is a follow-up event to this that I would like to release because I still have some codes to give away, and I do want to have this entire process replicated for people, other content creators who may want to replicate this. This is now a very nice worksheet to work with. All you need to do here is to enter the deck size, enter the number of lands in the deck, and then enter your data. The rest will be computed automatically. Okay, so I will be offering this as an event for other content creators who may be interested in trying this out for themselves, as seeing if we change the deck size and the lands, will the distribution still be what we expect. And of course, another thing is this is for best of 3 and not for best of 1. We know that for best of 1, there is an additional hand selector algorithm that does change the distribution, but not for the worse, right? It's supposed to change the distribution for the better by squeezing the distribution so that you get fewer 0 land hands, fewer 7 land hands, fewer of the extreme events, essentially. All right. Thank you everyone for watching. I'll see you again next time.